Good evening, everybody. I hope this for let's remember our previous two lessons, then we'll continue with our new lesson. We learned before about atoms and electric circuits. Let's begin with atoms. And we said atoms are the building blocks of all matter. An atom includes two main components. We said the center of atom we call it nucleus, and the second component electrons move around nucleus. Nucleus is the center of an atom, and electrons move around nucleus in different directions, and this area around nucleus we call it electron club. Then nucleus includes two main components, protons and neutrons. And we know protons have positive charge, electrons have negative charge, and neutrons no charge. So inside nucleus we have positive and neutral, means neutrons and electrons move around nucleus. Then we learned how to find the total charge of an atom. To find the total charge of an atom, we have three different cases. If the number of electrons equals the number of protons, here we have a neutral atom. Means if we have an atom includes 4 electrons and 4 protons, means we have 4 negative and 4 positive. So the total charge equals 0 or no charge, or you can say neutral. With losing and gaining. With losing and gaining. If an atom lost 1 electron or more, for example, the same atom includes 4 electrons and 4 protons, and it lost 2 electrons, means it has 2 electrons and 4 protons. So if it lost 2, the total charge will be positive 2. If it gains, for example, if it gains 3 electrons, means we have now 7 electrons and 4 protons, so the total charge will be negative 3. So with gaining we have negative, and with losing we have positive. Then after that we continue with electricity, and we said we have two types of electricity. We have static electricity and electric current. And we said static electricity means the buildup of charges on an object, means when we add extra electrons to the surface of any object by heat, or in general by heat. Then later we'll learn more specific information about static and electric current. We said static means it's not moving, and static electricity means the buildup of charges on an object. So if any object like the balloon, we added extra electrons to the surface, so it will stick to the wall because opposite charges attract and like charges repel. The jumping of electrons from one object to another, this is the meaning of electrostatic discharge. When we have movement with motion means electrostatic. So the jumping of electrons from one object to another, we call it electrostatic discharge. An example about electrostatic discharge, lightning. Then after that we continued with electric current, and we said the flow of charges through wires, we call it electric current. This is the first lesson. Then we continued with electric circuits. We began with electric conductor and electric insulator, and we said electric conductor is a material that allows electric charges to flow through it easily, and insulator means it resists the flow of electric charges. So we have we have conductor and we have insulator. So insulator resists the flow of charges. Example about insulators, we have many different examples, like for example rubber, like plastic, and conductor. It allows the flow of electric charges. An example about conductors, all metals are good conductors of electricity, and the best conductor that is used in electric circuits, copper metal. Then after that we continue with electric circuit, and I said before, don't mix between electric circuit and electric current. We said electric current means the flow of charges through wires. So we have circuit and we have current. So circuit means and current means what? Current, we said the flow of charges. Through a path of wires. And circuit means the path that electric charges can flow through it. So, the path of electric charges we call a circuit, and the flow means current. So don't mix between current and circuit. Then we continued with how to make a simple circuit. And we said we need tools, in general, we need 4 main materials, like source of electricity, like energy station or batteries to provide the circuit with electric charges. The second one, we need wires or conductors to conduct electric charges. We need a switch to open and close the circuit, and we need any device to change the form of energy. To change the form of energy means to change electrical energy to another form of energy. So, in general, we have battery or energy station, then wires, good conductors, then we have switch, and for example, we have light bulb. And here, this is the switch. So, this switch is open, so electric charges cannot flow. So this circuit, we call it open circuit. If we close the switch, here electric charges can flow, and then we'll call it closed circuit. So with closed circuit, light will work. Open circuit means no light. If we have more than one electric appliance in our houses or in the school, for example, we have 2 ways to connect these devices. The first way of connecting circuits, we call it series circuits. And the second one, we call it parallel circuits. The main idea here, with series we have only one path, and here we have several paths. The second idea to compare series and parallel. If one burns out, the others won't work. But here, if one burns out, the others will work. Now to know more about parallel and series circuits, I draw two graphs. The second one about series, you'll make battery or energy station, then wires, then for example the first device to the second, to the third. So electricity will move from positive to negative in this way through light bulbs and this way. So this is what we call it series. If one burns out means here cut. So we have open circuit, and we know with open circuit no light, and we have only one path, so electric charges cannot flow. The second type, or the second way of connecting circuit, we call it parallel circuits. In parallel circuits, I take the source of electricity, then I make closed path, then I make branches to connect light bulbs, for example. So, and this way of connecting circuits, if one burns out, so this is the first branch, the second, and the third. If one burns out, so in this branch no electricity, but this and this, we have closed circuit, they can move, and here they can move. So parallel circuits better than series circuits, because here if one burns out, the others will work, and series, if one burns out, the others will not work. Then we continue with overload, and we said overload means when we put many devices in one plug. And we said fuses and circuit breakers. Fuses and circuit breakers are used to prevent electric current. Fuses and circuit breakers circuit breakers are used to prevent electric current. When electric current comes too high, they open the circuit and protect our devices. And fire will not take place in our houses or in the school or in every building. Yes. Then the last idea in our last lesson about the measurement unit of electric current, we call it amperes or amps. So till here we finished the previous two lessons. Then our lesson today about so these are the main objectives in our lesson today about magnets. To define magnet and name its two poles, to distinguish between magnetism and magnetic field, and the last thing, to compare electric motor and electric generator. We know we use electricity in our houses, and we have many different uses of electricity. Without electricity makes our life easier. We use electricity, like me now, I use electricity in my laptop. You use electricity with fridges, ACs. We know. So life will be easier with electricity. Then, electric motor and electric generator are used in our houses and everywhere. So how we can compare between electric motor and electric generator? So from its name, we know what its job. So we have electric motor and electric generator. And here, motor. So we have two things, electric generator and electric motor. Its name what? Generator. So it generates electricity. And motor, it uses electricity. So electric generator generates electricity and motor uses this electricity. Then, so electric generator changes which form of energy to which form of energy. We said it generates. So it uses or it changes mechanical energy into electrical energy. Mechanical energy into electrical energy, because we learned how to generate electricity in the first term. And we said we have clean ways like green energy, by wind, by water, or by sunlight. So, electric generator changes mechanical to electrical. And motors, we use motors in our, like fridges, like ACs, like fans, they use electric motors. They need electricity to work, so they change electrical energy to mechanical energy. Then I'll send a video to support this idea. So, electric generator, it generates electricity and motor uses electricity. Generator, it changes mechanical to electrical, and motor, it changes mechanical energy, electrical energy into mechanical energy. So mechanical to electrical means generator, and electrical to mechanical means motor. Then we know about magnets. You took magnets before, but let's remember and let's add some new ideas about magnets. We know, or all of us, we know magnets, and we have different shapes and sizes of magnets. So to define magnet means what? Magnet means is an object that attracts iron and a few other metals. And it includes two ends. These ends, we call them poles, N and S. N means north and S means south pole. And like charges, if we have like poles, means N with N or S with S, they repel. Means they go in opposite directions. They'll push each other. But if we have opposite poles, means N with S, they attract. So like poles repel and opposite poles attract. N with N, S with S repel, N with S or S with N attract. Then magnetism means what? And magnetic field means what? Magnetism means the physical property of magnets. Physical property means any property that can be measured or described or be observed by using our five senses. So we know magnets attract iron and other metals. So this is the property, its name what? Magnetism. If we have a magnet and we put beside this magnet like metallic nails, from this point, it can attract these pieces. So it has force around it, but this force we cannot see it. Invisible force around magnets. So this area around magnet, or the force or invisible force around magnets that attracts objects, its name magnetic field, and you'll see a video that support about magnetic field. So let's see, then I'll send this link to you about magnets and magnetic field. So let's see this video. This video explains the power of magnets. So here this kid needs help. So how to catch these powder or these nails by using magnet? Then you'll see this full video to answer the worksheet that I'll give it to you later, inshallah. So we began with electric motor and electric generator, and we said electric motor electric generator generates electricity, and electric motor uses electricity. An electric generator changes mechanical to electrical, and motor electrical to mechanical. Then we continued with magnets, magnetism, and magnetic field. And we said magnet is an object that attracts iron and a few other metals. And magnetism is a physical property of matter. And magnetic field is a space around magnet where the force of the magnet acts. And to see this invisible force, we can use iron metal to see this force around magnet. Then you'll see this video. So you'll see two videos to support these ideas. Good luck, and I'll see you inshallah next video.